Hi everybody, today we're talking about properties of water, our essential molecule of life. Last lesson we learned about molecules, compounds, and elements. Today we're learning about one special molecule in particular, which is water, and we're going to be asking this question. What are the properties of water, and what are some real-world pieces of evidence for them? What you're going to be doing today is taking notes in your notebook. I'm going to have some guided notes on the screen here to teach you how to do Cornell notes, and we're going to look at some pictures as we go, and you can take notes on those. So at this point, your notebook should look something like this. I want you to make two columns, one for the learning intention and questions, and then the other one is going to be the main space for your notes. So this should be about a third of your page or less, and then 2/3 or a little more on this side. And you're going to leave room at the bottom today for a summary, which we'll do at the end of class. Okay, so what are the physical properties of water and some real-world examples of them? Well, before we get to that, we're going to ask this question. What images come to mind when you think of water? Maybe it's this beautiful seascape here. Maybe it's a delicious glass of water. And then maybe you think of something like this, Kool-Aid. How is it that we fit so much sugar into Kool-Aid? Have you ever had to make Kool-Aid? You put like 2 cups of sugar into that. It's crazy. Where does it all go and how does it stay in there? We're going to learn a little bit about that today. You've probably seen something like this before as well. Why does water pool up into droplets when it's on a leaf or wax paper or something like that? We're going to learn about this phenomenon today as well. You may have also seen this little creature before. It's a water strider. How does it stay on top of the water? Later in the school year, we'll be taking some specimens out from the pond out in the back there, and we'll see some of these guys, and you will, at that point, be able to tell me how it is they stay on top of the water. So we thought about what it is that you think about when you think of water, but now we're going to pretend that we are chemists. And when chemists think of water, they see this, and they might see something like this. And we're going to talk about what this means in a moment, but I just want you to now be kind of putting on a different hat. You're now not just thinking in everyday world, we're thinking in molecular world, where things are very, very small, and we're thinking about things like charges and electrons and protons. So today we're thinking like chemists. Here is a model of water. It is 1 oxygen and 2 hydrogen, modeled here by a red sphere and 2 white ones. So oxygen shares electrons with these 2 hydrogen atoms, and we call that a bond. Remember, we talked about that last lesson. So this is what it looks like normally, but it also has some special properties. Water forms something called hydrogen bonds, which help hold water molecules together. And it happens between this hydrogen and the oxygen here. And there's different ways that this can happen, and in different molecules and different elements can do it, but in water it's really special because it gives it all these properties. Hydrogen bonds make water a good solvent. They make it be able to adhere to things, so it has the property of adhesion, has the property of cohesion, which means it sticks to itself. It also has surface tension and something that we call capillary action. Okay, so these are all different properties that are around because of hydrogen bonds happening in water. At this point, our notebook is going to look something like this. We've got our learning intention. We're going to give it a heading of water, H2O. And then you can write hydrogen bonds form when hydrogen bonds form between water molecules and help hold water together. Properties due to hydrogen bonding are listed here. And you can make a little T-chart of the name of the property and then a real-world example. So the properties we have again are solvent, adhesion, cohesion, surface tension, and capillary action. And then also, as we're doing Cornell notes, you can write down questions that you might have as we go. I have some example questions here, and you can use these for today, but the goal is by the end of the quarter that you will be thinking about your own questions as you're taking notes. So I didn't tell you how hydrogen bonds formed. I just told you that they exist. Maybe that's one of the questions you have. What other properties does water have? I told you about these 5 right here. What else is there? Are there things that I haven't told you about? That might be a question you have. So you can pause right now, make sure you get at least what I have on the page done. You can ask other questions if you want to, and write those down. And then when you're ready, we're going to move along to the next slide. All right. The first property that we talked about is solvent. Water is considered a universal solvent, and a solvent is a liquid in which other molecules and compounds can dissolve. What do you know that dissolves in water? Well, we started with a great example, Kool-Aid. And Kool-Aid has lots of sugar in it, it has some flavoring, it has color, and all of that ends up being dissolved into it. It doesn't just separate out and sit down at the bottom. If you don't drink the Kool-Aid for a while, it stays dissolved in the water. And that's a property that's unique to water in some cases. Another one here, we have salt. Obviously, the oceans are made out of salt water, and so salt gets dissolved in water. What about this one? Oil. Does that get dissolved in water? No, it doesn't. And why is that? I don't know. I'm going to leave that one. That could be a potential question that you guys write down in your notes today. All right. So going back to hydrogen bonds, we said that hydrogen bonds help water molecules stick together, so it gives it its sticky qualities. Adhesion is when water sticks to other things. Cohesion is when water sticks to itself. And surface tension is like basically cohesion at the surface of a liquid. Okay, so adhesion, adhere, you can think of like putting a piece of tape on the wall that's adhering to the wall. 2 different things. Cohesion is when water sticks to itself. We can think of like cohabitate, anything usually means together or with. So in this case, water is together with itself. Adhesion, cohesion, surface tension, all of these are due to hydrogen bonds giving water its sticky quality. And let's look at some examples here. Here we've got both adhesion and cohesion going on. Why does water form droplets? Well, if we look at this water droplet right here, what's happening is all the water in this little droplet wants to stick to itself. So they're all being pulled together by these hydrogen bonds, and they don't want to stick to this leaf. So there must be some chemical property to this leaf that means that water doesn't want to stick to it. Okay? So in this case, that's an example of cohesion, and then adhesion would be if the water was sticking to the leaf. And in this case, there isn't any adhesion, which is also an interesting thing to note. Okay. Another property we talked about was surface tension, and this water strider is able to stay atop the water because the hydrogen bonds at the surface of this water are pulling the water tight across the surface. And that allows bugs and other small things to stand on the water. And it turns out that these bugs will have like proteins and things on their surface that don't like interacting with water, and it will actually repel them away from the water in some cases. All right, and then our last one was capillary action. How does water go up a paper towel, as in this example here? The water is getting pulled up through the napkin here. That's something called capillary action. And capillary action is when water, due to its hydrogen bonds, will move up, down, or across the surface. The water here is adhering to the napkin, and then other water molecules are getting pulled up by the hydrogen bonds. So now we have more water in the napkin, which means more water can move up further into it through capillary action because it's adhering to the surface of that napkin. And then more water molecules get pulled up and so on, and it creates this positive feedback loop where all the water will eventually get pulled up into the napkin. And this is fighting against gravity, if you think about it. So it's actually a fairly strong force that it's able to bring water up in opposition to gravity. Okay. Then last but not least today, what you can do is write down a summary of what we have learned today. I have an example of a summary here, but we're going to pause for right now. You can write down these different properties that you've learned, the real world examples that I gave you, and then write up a summary, and that'll be all that you need to get done for today. And then tomorrow we're going to do the properties of water lab. So you need to do this, you need to have your notes done before you can do the lab tomorrow. Okay, so I will see you all tomorrow. Good luck.